Welcome to all of you. Today we will learn the data pre-processing step, and that step is known as one-hot encoding.
Now let us discuss about the another important aspect which we used to perform during the data pre-processing, and that one is known as encoding of categorical data. Now see, the almost all machine learning model understand the numerical type of data. For example, there is a data set containing data regarding, let's say, age and height of the people. So here this age is a numerical value, right? It may be like a 20, 21, 20 or 30, right? Whereas height is also a numerical value like a 5.4, 5.6, 5.9 or 6 feet, like that. Since both of these columns are containing the numerical value, it is possible to establish a relationship between them. For example, so and so age person may have a so and so height. The same thing is done by the machine learning model. It become easy for the model to understand the relationship between the numerical type of data, since they are the numbers, and the numbers can be compared, right? So there are actually two important points which we should always consider for the numerical data. This numerical data can be compared. That is the first important thing. Second important thing is numerical data can be used in calculation. But sometime we will have a textual data that will also contribute to the final output. For example, take the data set that contain this home price, town and area. Now this home price are dependent on town where they are located and the area of construction both, right? So here this town column contain the textual data like Monroe Township, West Windsor, and we are having a Robbinsville. Now this let's say suppose this Monroe Township is a more developed place compared to West Windsor. Then the house located in the Monroe Township may have a higher price than the house located in West Windsor. This is the effect of town where the house is located, right? Now most of the time this textual data represent the categorical data. So please remember, this categorical data represented this limited set of value. For example, let's say gender column. Now see, this gender column can contain only two values like a male and female. Hence you can say this gender is a categorical variable. Similarly, if you see this town column, so this town column contains three values like we are having a Monroe Township, we are having a West Windsor, we are having this Robbinsville. Now we can consider this town as a the categorical variable. Now this textual data, or you may say the categorical data, cannot be understood by machine learning models. Then the concern is, how can we use this textual data to predict the home price, since this machine learning model can understand only numerical data, right? Then the solution is, we should convert this this textual data into numerical data, right? So that is the only possible way. Now there are basically three ways through which we can convert the textual data into numerical data. The first way is simply assign a numerical value to the textual data. That actually we do under this label encoder. Similarly, we are having an approach for dummy variable that we will see a little later. So let us discuss first about this label encoder. So basically what it does, let's say we can this under this label encoder, we can replace this Monroe Township let's say with 0, Robbinsville let's say with 1, and this West Windsor we are going to be replace it by 2. So after conversion, this town column contain this 0, 1 and 2 as you may see over here. So this type of conversion is called label encoder, right? So for that regard, this label encoding can be done by using this label encoder class of the pre-processing module of this sklearn package, right? And then we create one object of this label encoder class, right, like this. Then we apply label encoding on this town column by using this fit transform method. So basically this fit transform method firstly sort the value in town column into the alphabetical order. So I mean, if you apply it, so it is going to be appear in form of alphabetical sorting, I mean alphabetical order. So firstly Monroe Township will come, followed by Robbinsville, and then it will put the West Windsor, right? So basically what is going to be happen, this Monroe Township is going to be represented by 0, the Robbinsville is going to be represented by 1, and West Windsor is going to be represented by 2, because it is the alphabetical sorting. Now see, this fit means we are going to be perform the training, and then by using this transform means we are going to be convert, right? So the method this fit transform firstly understand the value in the town column, and then this transform convert them into the form of 0, 1, 2, like a numeric value. But the problem here is I mean with this label encoder is that numerical value like 0, 1 and 2 can be misunderstood by the machine learning model. For example, the model may think that 0 is lesser than 1 and it is lesser than 2. Hence the model takes that Monroe Township is a less important township than the West Windsor. Since the average of 0 and 2 is 1, maybe the model can think that Robbinsville is the average of both Monroe Township and the West Windsor. So, this kind of absurd interpretation can be given by the model, right? That's why this label encoder is not recommended in such kind of context. Now, we are having another approach through which we can convert this categorical information into the numerical, and that approach is by using the dummy variables. So basically by using this approach we are converting the data by using this dummy variables. So a dummy variables, as its name is indicating, is the intermediate variable by which the categorical data can be represented, right? So this dummy variable contain basically the binary value like either 1 or 0. So to convert a column into dummy variables, we can use this method get underscore dummies function, and this is available in pandas package, right? So here we are converting this town column of the data frame into dummy variable, right? The resultant dummies object contain the data which is like this, right? Now the get dummies function basically sort the textual data of town into the alphabetical order. Then it convert the data into binary digit in the sequence. Like this Monroe Township we are representing by 100, and then it will this Robbinsville we are representing by 010, and then West Windsor we are representing by 001. Now if you recall, one important assumption in linear regression model is that independent variables are not dependent on each other, right? So they should be completely independent from each other. That means there should be no relation exist among them, right? But dummy variables are actually opposite to the statement with the assumption of the simple linear regression. They will not behave like a completely independent variable. For example, in dummy variable, if you know any two values, right? If you know any two values, then the third value can be easily predicted as 0. Similarly, if you know that first two values are let's say 0, 0, right? Then you can easily predict the third value. It should be 1, right? So in this manner, the machine learning model can easily establish the relationship between them, and that's why they are not completely independent. So basically this problem is called as dummy variable trap, right? So this dummy variable trap is a scenario where there exists a relationship between independent variables, and any two can predict about the third one. So by using two, you can predict about third one. Now to overcome this dummy variable trap problem, simply what we have to do is we should drop a value from the three values, right? So any one of this value, any one of this one of the column we have to drop, and by that way we can get rid of this dummy variable trap issue, right? So for example, if you will drop it, then one of the column, let's say I am dropping this West Windsor column, West Windsor, that is the third column out of it. So that is the resultant now. Now by this resultant, this Monroe Township is going to be represented by 10. Similarly, Robbinsville we are going to be represented by 01, and West Windsor we will represent by 00, right? So that is the idea of it. So after executing this statement, now the next statement is this, right? What we are doing over here, let's say access is equal to column. It means that we are going to be drop the total column by the name West Windsor, right? So after that, after dropping it, what we are doing a concatenation of this data frame with the DF data frame, right? And after doing it, if you see, this is the resultant outcome, right? So this is the resultant outcome. Now see this, what we have done, what we have obtained over here, basically this town column we have represented by this two column, right? That actually we have done by doing the encoding, right? So this categorical data actually we have substituted by this numerical data. Now this town column is not relevant at all, because this we have converted into this numerical one, right? So after this we can simply drop this column, because this is absolute now, right? So what we are doing in this statement, we are dropping this town column, and this across this entire column we are dropping out of the data frame. So this is my final data frame which we have created after removing this after performing the encoding over the categorical data. So now my data has prepared, right? Now my data is ready for passing this value to the any model, right? Now here the final, what we want to do is, by seeing the township and area, we want to predict the price. So let's find out the x and y value. So x value will be all this three column apart from this price, right? So this x we have extract out of this data frame. Similarly, we extract the price from this data frame. So this is my y. So after getting x and y, now I can apply any regression technique for finding out, for predicting the price of the house for the given area and township, right? So I am now training the model by using simple multiple linear regression, because two input we are having. Based on that, we have to predict the price. So I have trained my model. After training, let's say check what is the price of this value. So now the area we have given. So my model has been trained. Now I am performing the prediction. So let's say I am having an area 2800, and this township is Monroe Township, and that we have given as an input, right? So it is a Robbinsville, right? 01 means it is a Robbinsville value we are having. So if you give this value, then the price of the house in this area having an area of 2800 would be this one, right? That is the meaning of it. Similarly, if you give the different value, it will tell you the corresponding output, right? So that is the idea how actually this will work, right? Now the accuracy of the model which we have trained, that would be 95.73. Okay, so now the another approach we will learn, that is the third approach, that is known as one hot encoding. So basically this third approach also we use for converting the categorical data into numerical one, and this technique is known as one hot encoding, basically which gives us the output as given by the dummy variable method. So in this there are two stages. First stage is we use the label encoder, and then after that we will see the next step. In the first stage, what we does, we have to convert the categorical value into 0, 1, 2 by using this label encoder. So that we have done by performing this operation. So you may see now the town column value will contain only this 0, 1 and 2 value, right? Now Monroe Township we are representing by 0, Robbinsville it will be represented by 1, and this West Windsor we are representing by 2. Now in the second stage, so now we are retrieving this x value, that is the town and area. So this is the value of x, this is my y value, right? Now in this second stage, what we does, we convert this value into the binary digit by using one hot encoder, right? This one hot encoder class of this sklearn pre-processing module, right? So what we does, we firstly create one hot encoder object like this, right? Now please observe here, the attribute is handle underscore unknown is equal to ignore. So basically this tells us the one hot encoder to ignore the categories that cannot be converted. Now we apply this one hot encoder on town column, right, with the help of this fit transform. So this will basically give us the sparse matrix. So basically the sparse matrix contain many zeros as element along some integers. This matrix can be converted into array using this to array method. So this is a statement which convert the sparse matrix x1 into the array and then into the data frame, right? So with this, if you display this x1 value, we can find them like this. Now this shows that the town column has been divided into 3 parts and numbered as 0, 1, 0, 1 and 2 columns, right? The column values are indicated like this. So here again, the Monroe Township we are representing by 100 and Robbinsville we are representing by 010, and whereas this West Windsor we are representing by 001, right? Now that the encoding process we have completed, now we have to drop a column from the above 3 columns to avoid the dummy variable trap issue. So any column can be dropped from this 3 column. Suppose we want to drop 0th column, right, and take the only first and 2. So we can write it like this, right? So here I am dropping the 0th column and remaining I am writing over here. Now we will see one by one how to apply this dummy variable method and one hot encoding that we have seen actually. Now after performing this step, now my model is ready where we can apply any modeling, right? So this is my x value. Now I am concatenating this x value with the original data frame. So that is the outcome of this. So actually this town we have this was a categorical data that we have encoded by the label encoder, and then finally this is the value which we have obtained after completing the third method, right? So now this town is absolute for us, so we have to delete this column out of it. So that we have deleted. Now this is the value which we are having with us. Now y value, we also know the y value, that is a price. Now I can apply the multiple linear regression on this data frame, and we can perform the prediction, right? So simply I am applying this multiple linear regression on that. So once we have done it, my model has trained. Now you can give any input value, in our model will predict what would be the expected value of that price of the given house having this area and the township, right? Again, the different value I have given, it will tell you the price corresponding to that. So as per this, my model accuracy is 95.73, right? So that is something which we have obtained after performing the label encoder, right? Now we are having a, let's say one more example I am having with us. So where again I will tell you that how to convert the categorical information into numerical one, because the fundamental thing which we have to clearly understand that the textual information I cannot integrate, I cannot use for doing the machine learning modeling, right? So we must convert it. So for that regard, we have discussed this 3 approach through which we can do this conversion. Now here I am taking the different data. So this data set has the data about the car model, I mean the car name, the mileage, mileage means how many miles it can be roamed, and the sell price in dollar, and age of the car in years, right? So there are basically 4 columns, and we are having a total 13 rows in this data set. To predict the price of the car, we have to consider not only the mileage and age, but also the model of the car, right? For example, BMW car may have a more price than the Audi car, hence the model of the car will also influence the price of the car. So now the car model column contains this limited model name like a BMW X5, this Audi A5 and the Mercedes Benz C class. Hence you may say this car model is a categorical variable. Now using a one hot encoding technique, what we will do, we will convert this categorical information into the numerical one, and then after that we will apply the multiple linear regression on that. So that is a task which we need to perform. So before, if you recall, for applying the multiple linear regression, we must see the the dependency, the relationship between independent and dependent feature. So for that regard, I have done this plot. So if you plot between mileage versus sell price, you may see they are having a linear relation, right? Same thing is true with the age and price, age and selling price. They are also having a linear relationship, right? So with, they are satisfying the assumptions, right? So once we establish this relationship, now I am ready to apply the multiple linear regression on that. So this is the process through which we can apply we can convert the categorical data into numerical one by using one hot encoding. Firstly, we have to apply the label encoder that we are putting over here. Now by that way, this car model values has been converted into this 102 as alphabetical manner, and then we have separated this X value from the data frame. So this is my X value, right? So that I have separated. Similarly, Y value I have separated. I have retrieved from the data frame. So this is my Y value. That is nothing but the sell price, right? After doing this, now we are applying this one hot encoding on the car model. So this is the class which we have to encode, and then we have to make an object of that class, and then we have to train it, right? We have to train and transform this value. So once you have done it, so this would be the output of that, right? So again, x1 is the sparse matrix that we have to convert into array and data frame. So this is the x1 value which we are having. So now after doing this, now my data has been converted, right? My data has been converted into the numerical one. Now I can use this numerical data for doing the training, right? So this data set I have taken, now I am applying this multiple linear regression on that. So for the training purpose, right? So now by using this data, which is already pre-processed, in which there is no categorical information, now that data is ready. Since there is no outlier, there is no missing value, and we have also converted the categorical data into the numerical one. Now my data is ready that I can give to directly for doing the modeling, right? So simply I have passed this data to the linear regression model. Here we are applying the multiple linear regression. So by that way we have trained the model, and now you can give any value. This will tell you what would be the expected price of that one, right? So here we are predicting that Mercedes Benz that is having a 4-year-old with the mileage of this much, what would be the expected price of that? So as per our model, this much would be the expected price of this given detail. Similarly, for this detail, you may see this would be the price of the car. Now, if you want to see the score of this model, so you may see that 94.17% would be the score of this model.
Now, let me summarize what we have learned in this one hot encoding. So basically, machine learning model cannot recognize the textual data, or you may say the string or images, right? Hence, this string and images should be converted into numeric data. So here we basically use a label encoder. So in this label encoder, basically the data is replaced by 0, 1 or 2 kind of numerical digits. Now here we use the method called get_dummies. This function basically convert the categorical data into binary digits like 100 or 010 or 011 like that. So basically we are having one more method that is known as one hot encoding, through which we do this conversion. So this one hot encoding also converts the categorical variable into the binary digits like 100 and so on, like. So when we use this one hot encoding, we should first use label encoder and one hot encoder class. One important assumption in a linear regression model is the independent variables are not dependent on each other. So this dummy variables are the intermediate columns created by get underscore dummies and one hot encoder. Now when these dummy variables are dependent on each other, it is called as a dummy variable trap. So to avoid this trapping, we have to remove one of the dummy variables. Thank you.